Hi, my name is Jake Audet. I'm going to be taking the test today. I'm going to be doing problem 1 of the test, starting with A, which says an electron is resting at a distance of 1 meter from the center of a nucleus of lead. You may treat both objects as point charges. How much work would you have to do to move the electron to a distance of 5 meters from the center of the lead nucleus? So I'm going to make my diagram first. This is our initial position. Had to charge the negative initial, and over here is our other, and then our target nucleus is down here, so it says 82 plus E, and then there's a 1 meter distance between them. And we have it also says, and then how much work you have to move the electron to a distance of 5 meters from the center. From the center. Meters. Okay. So how much work do you have to do to move this electron from the center of the thing? Okay. Well, work is going to equal electric potential energy, and in this case it's going to be the final minus the initial, and electric potential energy equals K to the charge of the 1, charge of the 2, and over R, which is our distance. So we're just going to plug in our charges, our distance, and our K, and our K is going to be constant. It's going to be 8.99 times 10 to the 9th of our first charge given, which is negative 1.60 times 10 to the negative 19. And our second charge, which is plus 1.31 times 10 to the negative 17 over our distance, which is 1.1 meters. Oh, sorry. It's 1 meter times 10 to the, it's 1 times 10 to the negative 10 meters. I'm going to plug all this in my calculator. This is all going to equal U, by the way, or electric potential energy. And this is going to give us our initial electric potential energy, which is going to equal negative 1.89 times 10 to the negative 16, and it's going to be in joules for the answer. I'm sorry, I'm just going to write a regular J here. And now we got to find the final. And to do that, we just divide it by the other distance, 5, which gives us the final. And now we are going to do the final minus the initial. I'm going to put that in the calculator right now. Which gives us 1.51 times 10 to the negative 16. And it's going to be in joules. So there we go. So work for the first one. And now we have B. If you release the reaction from position A, well, what's kinetic energy be when it's at a distance of 8 meters from the center of the nucleus, not 5? You assume that the same, such as much more massive than the electron. Okay. Huh. Okay. Basically, the electron says it's starting at rest. So I assume the initial kinetic is going to be 0. It's starting at rest. So we just have the final And after moving it around, it's going to equal, I'm pretty sure, electric potential energy initial minus the final after moving it around, since that one equals 0. And to do that, we have the initial, which is right here, but we need the final, which is going to be U equals, again, K times the 2 charges over R. So we're just going to plug it as 8.99 times 10 to the 9th. And then our charge. Oh, yeah, I'm just making sure you can see well. I hope this is not too late. I'm just going to zoom in a bit for you. I just noticed. I am so sorry. Okay. Oh, okay. And then sorry to interrupt, our second charge over the new distance, which is 8. And that's 12, right? Yeah, negative 12. And we'll put this all in my calculator. Just divide that by. Oh, okay. Which is going to give our final equals negative 2.36 times 10 to the negative 15. So now we just take our initial, which is up here, 89 times 10 to the negative 16, plus, because there's 2 negatives, 2.36 times 10 to the negative 15, which would equal our kinetic energy and that's plus 1.89 times 10 to the 16. One second, just going over my answer. And okay, sorry, just go over here. 1.89 times 10 to the negative 16 plus 2.36 times 10 to the negative 15. Times 10, 16. Okay, which just gives us 2.1. Sorry, I got an error. I had to redo the entire thing. Times 10 to the negative 15. And it's going to be in joules. Awesome. Moving on to C. In a nuclear physics experiment, a proton, the mass and charge is fired directly at a target nucleus. A unknown charge. You should use both charges as point charges. Okay, give it a velocity. Okay. Okay. I'm gonna make the graph first. Okay. We have U up here with the mass of 1.67 times 10 to the negative 27. And then down here we have E, okay, which also has a mass of 1.67 times 10 to the negative 17. And the distance between them is gonna be 5.29 times 10 to the negative 13 meters. And then over to the right, the velocity to this mysterious target nucleus is going to be V equals 2.5 times 10 to the 6. I've done this problem before, so I'm going to just make there's also later asked for the second charge for part D, so I'm just going to label that down here as Q. That we don't know the charge of it yet, though. That will be in part D. And some mystery. Okay. Moving on, though. Okay. Well, we're given mass and velocity, so I know we're going to use kinetic, but that's all we can use because the proton is very far away, so the electric potential energy is basically going to be 0 because it's infinite 0. So we're just going to use initial, and it also says the proton momentarily stops later, so the kinetic F, or the kinetic final, is going to be 0, so we're just going to solve for the kinetic initial, and the formula for that is 1/2 mass velocity squared, which we are given all of that, so that essentially equals the U. So U equals kinetic initial equals 1/2 the mass 1.67 times 10 to the negative 27, the velocity 2.5 times 10 to the 6 squared. Okay. And our U will equal, give me 1 second. (5.22 times 10 to the negative 15), and that'll be in joules. Moving on to D, though, I'm gonna just make my lines here for you. Okay, sorry. Just in case you want to go back and you don't want it to be cluttered. Apologize. Okay. So I'm going to be going on to D now. Move this over a bit for you. Okay. And D is asking what is the charge of the target nucleus. And to get the charge, we can just move around the electric potential energy and set it equal to we're looking for the charge of the nucleus, which is the second one. Just gonna, then we just move it around basically and set U, which we just found, time over the U, okay, times the distance over K times the other charge. All right, and I'm gonna plug that in. Q2 equals, we just found out, 5.22 times 10 to the negative 15. Our distance, 5.29. $13, and then our other charge, which is given as 1.60 times 10 to negative 19. I'm going to put all this in my calculator now. Which gives 1.92 times 10 to the negative 18, C, or Coulomb. And then, yeah. There we go. All right. And then that would be the charge over here. The charge over here. Okay. Moving on. Part E, 2-point charges. I'm just going to move this over now so I can get a better... This is what we're talking about for D, though, right here. I'm going to just move this over so I can just be more comfortable handwriting or writing. E. Halfway. All right. 2-point charges are at a fixed position on the y-axis with Q1, Q2, Q3. From infinity to being at rest at y equals negative 2a. Well, I'm going to make a y-x graph, or just honestly just a y graph, since we don't really need x. I mean, I'll add x, though. There's no harm in adding x. We have y equals a, y equals 0. I'm just checking if you can see this accurately. Okay, there you go. Y equals negative 2a, and then that equals plus e, negative e, and negative e. Okay, and it's going off into infinity. And we are being asked to find the work. Okay. Okay. Well, first, we have a distance. Okay, wait. First, Okay, we have a distance of 2a, and for our next one, we have to do a minus 2a, the initial minus the final, equals 3a. 2 equals 3a. Okay, we got our two distances now. Now we're going to use the electric potential, the electric potential at a point due to point charges. So that's going to look like V equals K. K also in this is going to be, I'm going to write it as 1 over 4 to the pi, just because it's a lot easier later on. But, and then in our end, we have E for our 2a, and our negative E gets the 3a. I'm going to now factor out the thing, E and the a, just because it's going to make it easier for me. So I'm going to write it as V equals, I'm just going to write this as 4 pi now, e to the 0. And I'm going to factor out the E and the A. So that just leaves 1/2 plus -1/3, which that would equal, this would equal 1/6, which would then times that, which should just be E over 6 times 4 is 24, 24 pi, 0, and then A. Okay. Which would equal our point charge. Okay. Then we are then going to plug in we're going to plug in our third charge. We're going to set that potential energy equal to the third charge and times that to the V. And our third charge is a negative E. And then times that by our V, which would, I'm just going to write V because I don't want to write the whole thing again. It's just going to be a negative E squared over negative 24 pi A. Okay. Which would equal our work. Awesome. Moving on to, sorry, my computer's just being really funky today. Can you please load? Stop. My internet keeps cutting out. Okay, part F. Like, part F. Find the total potential energy of the system of the 3 charges. Okay. Yikes. Okay. Well, so we have to find from 1 to 3, 1 to 2, and 2 to 3, which is going to look like our 1 to 2. We're just going to do this one first, which essentially, God, that's a lot. Okay. I'll just remember this one. 1 to 2 equals A. And then we do U to the 1 over 2, or potential energy to the 1 over 2. And then we do 1 to the 4 pi. And that's our 1's going to be plus E. Our 2 is going to be negative E over A, which would give us a negative E squared over 4 pi. Okay. So I'm just going to apply this for the next two. I don't really want to write it out. I hope you imagine that I'm going to apply the 1 over 4 pi is 0 times the other ones because I have to do, actually no, I'll just write it out. Sorry, I don't know, I'm going to make any excuses. 4 pi, and for this one it's going to be negative E and negative E for the third one. And this is for our 3A, so this is actually going to be 3, and therefore 3 times 4, which is going to be 12. Then we have, we have another one, we have one more. We did 1 over 2, we did 2 to 3. I didn't do 1 to 3. Okay. 1 to 3. And 1 is going to be plus E. That's going to be negative E. And then this is going to be for 2A. So that's going to be squared negative over A pi. Yeah. 0. Sorry. Okay. Now we add all these up. And I'm just going to take the fractions from all of them. 4, 12 minus which is going to give okay, -7 over 24, and then I just times that by the rest of the equation, which is going to be -7 e squared over 24 pi 0a. And yeah, you got it right. Okay. And that is the U total. All right, 2 more. Since we're going back to here, I'm going to move this over. Gee, we're going to point charge, positions. We're asked to find what is the value of the second charge, and we're given a point charge, given distances, we're given work. Okay. So if we're given work, okay, and we're asked the second charge, we're just going to do what we did earlier. This is for G. And let me make my graph real quickly. Well, actually, this is part of the second one, so I'm going to quickly solve this before making this one, just because it's pretty easy. I'm going to get it out of the way. But for the work equals, so since it give us the work, we're not going to put U equals to the electric potential, because work equals the electric potential energy, and we're given the work. So we can just, I'm just going to write work of K, Q1, Q2 over R, and we're looking for Q2. So we're going to move that around, WR over K1, and then we're just going to plug everything in like we have been doing, which is going to be 8.10 times 10 to the -6 of 0.04, because we got to move that over since it's in centimeters, and then 9 times 10 to the 9th, and our first charge 10 to the -9. Okay, I'm gonna that's my nose. I'm gonna put this in our calculator now. My calculator. Okay. Which gives us 7.21 times 10 to the -9 coulombs for our charge. Okay. Sorry. Oh, my hand's getting tired. Okay. Now I'm going to be making the graph for, it's both part of them. For H, it says, once the second charge is in place, how much additional work would you have to do to bring a third charge from infinity into the position? Okay. So now I'm gonna make a ZXY. I'm gonna make a ZX plane. Put Q3 here. Q2 here, Q1. Actually, I mean, You just do Q2. We have 7.2. Actually, thinking, hold on. I know I want to put Q3 here. Okay, we're gonna put Q2 here, Q1 here. Okay. And distance between these is 4 centimeters. I'm gonna put it in centimeters here, I hope that's okay. Between these is 9 centimeters. This is going to infinity. Also going to over here, to which our charge equals 12 coulombs. I have a bad time pronouncing that. And then, yeah, okay. Okay. So now let me set up our next problem. Because we're being asked to find, how much additional work. Okay, additional work. Okay. So again, we're gonna have to do, from earlier, we're gonna have to do work equals the third charge, which is including, times the point charge, but we don't have that. So again, I have to do K of Q, but this time Q1 over R1 over R2. Okay, and we have multiple distances we're given, so R1 from charge 1 to 3 is, you're gonna have to square both of these and take the square root to get the distance, and it's gonna be y minus squared plus 0.03 minus 0 squared. It should just nullify it, give 0.3, yeah, because we squared it and then square rooted it, it's just gonna go back. And then we do from 2 to 3, from charge 2 to 3, and we have 0.04 plus 0, yeah. That, I'm gonna put that in the calculator. Squared plus, I don't even have to put the negative because it's squared. Oh my god. This gives us 0.05 meters. So now we have our R1 and our R2, and now we just plug everything in, which would be E equals 8.9 times 10 to the 9th of 5.00 times 10 to the negative 9 over 0.03 plus 7.21 times 10 to the negative 9, 0.05. Okay, I'm going to put all that in my calculator and then times it by the third charge. So, 1 second, do this part first. which gives us 2794. And now, just plug that back in over here for our work, and it gives us the third charge, which is 2 times 10 to the negative 9 times 2794. Second, hopefully, yeah, we're still recording, and you can see this perfectly. Okay, almost there. Come on, spread the rest of my calculator. Which gives us 5.59 times 10 to the negative 6 joules. And that is the final one. I mean, again, if you want to see, hopefully you watched the whole video. I don't know, but there we go. Okay. Thank you so much for watching, and have a good day.